Hey guys, welcome back to my tutorial. This is Utkarsh from Sunsoft Technologies, and today we'll be discussing Python literals. So a literal is data whose values are determined by the literal itself. Let's talk about the binary number system because that is the number system that our machine uses to store numbers or any kind of data actually. So a binary number system is made up of zeros and ones. For example, 1010 is 10 in decimal. Now, as the integers are stored in computer using bits, the numbers use 2's complement to be stored. We'll see this later on when we go to bitwise operators. Now, octal and hexadecimal numeration systems are also there, which use 8 and 6 as the base for their number system. Like the decimal number system is of the base 10. Similarly, binary number system is of the base 2, and octal is of 8, and hexadecimal is of 16. So for the hexadecimal system, they use 0 to 9 digits, and then after that they use A to F letters. So now floats are stored in computer using the IEEE 754 standard. Now unfortunately most decimal fractions cannot be represented exactly as binary fractions now because it uses the bits anyways, so that those bits are the ones that are used to represent those fractions as well. So because of that, the numbers that we enter as decimal are approximated. They are not exactly the decimal points. Okay, so now but Python rounds off the result of these expressions and hence give us the most approximate value, which is the most appropriate according to the approximation, which usually provides us with correct answers. So now let's discuss some type of literals. So we'll see integer literals, float literals, string literals, and booleans. So firstly, let's discuss integer literals. Now, integer literals are used to represent whole numbers. Whole numbers can also be represented by other number systems such as binary number system using 0b as a prefix. Let's see some examples of these. I'll open up PowerShell. Yeah. So let's open up the Python REPL and see some examples of literals. So when I say literal, when I say integer literal, this means any number. So 23 is an integer literal. It printed out the literal. 29. See, what this means is that this literal is giving the value of the number 23 inside our computer. So we have, let's say, 90 or any whole number that you want to give, 1, 2, 3, anything. So these are integer literals. Now this is the decimal number system. We are using the decimal number system, and when you're using the decimal number system, you don't need any kind of specific notation that this is in that particular number system. But when you want to use the number in binary number system, what you have to do is write down 0b. This is the prefix. Now this is the prefix for a binary number system. We saw 1010 is 10 in binary number system. I'll write it down. 1010 in binary. Now that is the representation for the number 10. Clear? Now if I want to write down this same number in, let's say, octal, so 0 O. Please remember that this is 0 and then this is O. O for octal. So now octal is of digit. How many? It contains 7, 0 to 7. So completely 8 digits. So for 8 digits, sorry, yeah. So for 8 digits, we'll have 1 and 2. This will make it 8 plus 2 gives us 10. Similarly, 0x. Now x is for hexadecimal. Now for 10 x in hexadecimal, we have a single digit, the a digit. 0xa will give us 10. See how differently we used And for if you want just a 10, then you can just write 10. So this is decimal, this is hexadecimal, octal, and binary representation. So these all use different notations for different ones. Now let's study what's the next. We have floating point literals. Now these literals are used to represent decimal numbers with fractional part as well. Now they can use the standard notation as well as the dot notation. Let's see what those are. So when I say dot notation, I can mean the dot notation. Now this is represented as a floating point literal. See, decimal numbers with fractional part as well. So this is the dot notation. But what if I want to represent a very big number, let's say Planck's constant? In science you must have studied it. Yeah, so its value is 6.62 multiplied by 10 raised to the power minus 34. So how do you represent that? Now you know that the base you're using is 10 in any number that you're seeing. This is decimal, base is 10 only. So the base you say is 10. Now you say for representation of the exponent, what did we say? Planck's constant was 6.62 multiplied by 10 raised to the power minus 34. So you only need to know first of all this fractional part, and then you need to know what is the exponent. So this is the E notation. This is the standard notation. See? So this E can be small and it can be big as well, no issues. It can be capital letter, small letter. So this E will tell us what is the exponent over 10 in this number. So let's say if I write down, so this is the standard notation that Python will use for its own. See, it automatically went all the zeros ahead, and when it found the first significant digit, it went 5.67, and then E, however many zeros it counted. Okay, E minus 26. Similarly, if you were to put zeros like this, yeah, then it will show this only. But what if I wrote 6.78 e raised to the power 34? See, then it's showing plus 34 only. Depends on what you're giving. This is basically an integer literal, so it is going to show it as it is. What if I put this? See what it's doing now? 6.788 e raised to the power plus 41. So the standard notation is for floats only. It's not for integer literals. Now we go into another type, string literals. Now string literals use special notation with double quotation marks or single quotation marks as the delimiters for denoting a string literal. Now we've already used string literals to pass text data into the print function. Let's see them working. So these will represent text. So let's say I want to say hi. So these will, see, that is how it stores hi, single quotation marks. Or I can use single quotation marks as well. Hello, no issues. So these are basically string literals. Now, now what if I want to use quotation marks inside my string? Let's say I want to say he said good day. What will happen? Now it is telling me that this is invalid syntax. Why is this invalid syntax? Because see, the interpreter went, okay, this is the starting double quotation mark, that means this is the start of the string literal. It started from there and then it went here. So that means in for the Python interpreter, this is the whole string literal, and then it witnesses some other code which it cannot properly interpret, because good day is not a proper keyword in Python. So it says from good day, from G it is invalid syntax. So what do I do if I want to put double quotation marks in my string? One thing that I can do is make the delimiters single quotation marks. Now if the delimiters are single quotation marks, you can put in double quotation marks inside, you can use double quotation marks. See, it does not have any problems. And then, but what if I want to use single quotation marks? If I want to use single quotation marks, then I'll put double quotation marks outside and then single quotation marks inside. Always remember to close your string properly. Now I do this, it does not have any problems. But what if I want to use both of them, both of those? So let's say uh, yeah, yes. So now what I'm doing is using double quotation marks inside a double quotation marks, and I cannot use the single quotation marks because I want to use single quotation marks as well inside the string. So now what I will do, see, first I'll run this again. Syntax error, EOL while scanning string literal. So this, now it went from there to there and it understood that this is the end of line. So what is happening? This string literal is one string literal for it, this string literal is one string literal for it, and this string literal has no end. So rather than this, what do we want to do is, because see the delimiters outside are double quotation marks, so I will escape these double quotation marks, not these ones, these ones. Now, when Python interpreter encounters these, it will know that these are simple double quotation marks inside the text and these are not to be parsed. Now it just shows us that that is the string. Now this will obviously show. So now by default Python uses this single quotation mark as the delimiter. So now it is escaping this single quotation mark on its own. Okay, now if we want to print it out, if we want to see what the text is, we'll use the print function and we'll see what the literal actually gets to. Now we'll print this, see, it's not showing any escape characters, now any escape characters, and it is not showing the delimiters. So this is the proper data that the literal returns. Now escape sequences can also be used to print other non-printable characters, just as we saw the \n. There are other escape sequences as well. We'll understand them later on. So now let's move on to the next type of literals, Boolean literals. Now there are only two Boolean literals. These literals are used to represent logical values of true and false. Please remember that these literals have a capital T and a capital F. So when I say true, false, you have to be very specific. What if I say this? See, you cannot use the small t. Why? Because this is not defined in Python. You have to use the capital T. That is the literal which is used to represent the true value of a Boolean. Now, what if I want to do this? See what the answer is. The answer is 22. So this value can be used, this value can be represented as 1. What if I want to add 21 to false? See, the answer is 21 only. So true and false are representatives of 1 and 0 respectively. So this ends our types of literals. I'll see you next time.